Hello and welcome to Mr. Linford's math course. In today's discussion, we're going to be introducing the topic of factoring polynomials. In particular, we're going to go through a series of videos of all the various techniques of how to factor polynomials. But in particular, for this video, we're focusing on what does it mean to factor? What is the definition of factoring? And how do we compare factoring numbers and polynomials? So the first thing, let's go ahead and let's try to define factoring. We're going to use kind of a working definition, but we're going to say factoring is the process of representing a quantity such as a number or an expression such as a polynomial as a product of other quantities or expressions. So let's take a minute to really go over this definition. When we're factoring something, we are essentially taking a quantity or an expression, okay? So you can factor down things like numbers. You can also factor down things like polynomials. And by factoring them, what we're saying is we are representing these things as a product. So we are now saying instead of taking a quantity and just writing a value down like a number, we're representing it as a product of other quantities. And instead of taking a polynomial and just writing a standard polynomial, we're representing it as a product of other polynomials. So let's go ahead and let's do some examples here. Let's start with the number 6, okay? We want to factor the number 6. This means we want to write it as a product of other numbers. Well, hopefully, that's not too difficult of a challenge for us. We can say that 6 is the same thing as 2 times 3. We could also say 6 is the same thing as 6 times 1. We could also say, hey, why not, that we could also have had -2 and -3, or -6 times -1. These are all factors of positive 6, okay? We have taken a number, a quantity, and we've represented it by multiplying other numbers together. So instead of saying the number 6, I could also say the number 2 times 3, okay? And they both mean the same thing. So let me write that down. 6 is the same as 2 times 3. So if I said the number 6, or if I said 2 times 3, you know what unit I'm talking about, what value I'm talking about, okay? Now this is helpful, really, because it might seem a little abstract of a concept at first, or a little unimportant of a concept, right? But this is helpful especially when we get down to simplifying quantities. Imagine I had something like 15 over 6 again, okay? And I said, let's simplify this down. Well, what did it mean to simplify something in terms of a fraction? What did it mean to simplify a fraction? That meant that you remove all common factors from the top and the bottom. What we used to do is say, okay, find what number goes into 15 and 6, or I should maybe say what largest number goes into both of them. So we would go and say, well, 3 is a number that goes into 15 and 6. So 15 is 3 times 5, and 6 is 3 times 2. And here we would say, okay, we have found the number that goes into both of them. 3 divided by 3 just cancels out. 3 divided by 3 is just 1. So our simplified answer is 5 over 2. This is how we determined how to simplify a fraction. All that we would do is we would remove or divide out the factor that they had in common, the greatest common factor. Greatest common factor is a 3 here, okay? That's where factoring became incredibly helpful. And we're going to see that later on when we start taking what are called rational expressions, in which we have essentially polynomials as numerator and denominator, okay? Now, that's something that we've explored before. You've been doing this since elementary school. Now what we want to do is we want to see if we can apply this idea of factoring, but this time to polynomials. So what does it mean to factor a polynomial? Well, here's an example. Let me take two polynomials. Let me say 3x plus 1 and 5x minus 2, okay? This, if I multiply it out, becomes 15x squared minus 6x plus 5x. Oh, wait a minute, that's just a negative 1x, isn't it? Because they're like terms. So that's just a negative 1x minus 2, okay? What we've just done here is we have a polynomial, and we have a way of writing it as the product of two other polynomials. This is something we've done when it came to polynomial algebra. You multiply two polynomials together, and you get a polynomial. What factoring does is it asks the question, can we go in reverse? Can you take a polynomial, and can you tell me what multiplied together to get you that? Okay? That's the same idea that we had with numbers. So, for example, 6, you said it could be 2 and 3, or 1 and 6, or the negative versions, right? And how did you know that? Well, you memorized times tables when you were younger. You went through and you would memorize things, right? And you would just rotely remember that the factors of 6 are 2 and 3, or 1 and 6, or the factors of 12 are 1 and 12, 2 and 6, 3 and 4, etc. But at a certain point, you stopped learning the factors, right? Like, for example, what if you had the number, oh gosh, let me think of something here. Let's say you had the number 126. So let's say you had to find the factors of 126. Well, I don't know about you, but I was never taught what the factors of 126 are. For me, yeah, we stopped pretty low as far as the numbers go. So I never really learned the factors of 126. So how am I going to figure what two numbers multiplied together to get us that? Well, one of the tricks that you learned was, what if you figured out what one of these numbers were? What if you knew that there had to be some number that was a factor of 126? And you learn different techniques for that. One number I know for certain that's a factor of 126 is the number 2. Because look, we have that trick that if your number ends with an even digit, then 2 is a factor of it. 2 times something get you 126. Okay, well, then how did I figure out what this missing number was? Well, we learned in algebra, very simple. To find that missing number, just divide both sides by 2. So 126 divided by 2 is 63. That's what that missing number was. So we can represent 126 as 2 times 63. So we had a technique for figuring out if you needed to determine what the factors of a number were. You could try to use these different techniques to identify what one of the factors might be. Here we use the technique of an even number. An even number is divisible by 2. There were other techniques out there, like I think to determine if something is divisible by 3, you have to show that the digits add up to be a multiple of 3. I think the trick for 4 was if the last 2 digits are divisible by 4, then the whole thing is. If a number ends in 5 or 0, it's divisible by 5, etc. There were all these different rules that students tended to memorize. And so that was one way we could go about figuring, all right, what are 2 things that multiply together to get us that number? Now, when it comes to polynomials, we can use a similar idea. So let me work through another example, but this time, you don't know what the factors necessarily are, or you don't know what both factors necessarily are. So let's take the polynomial 6x squared minus 5x minus 4, okay? And I'm telling you that we can multiply 2x plus 1 by some unknown value, some unknown polynomial, to get this trinomial, 6x squared minus 5x minus 4. So how can we go about and figuring what this missing polynomial is? Well, again, similar to our techniques we learned in basic algebra, we would just divide both sides to isolate the unknown quantity. So we would say that we could simply just divide 6x squared minus 5x minus 4 divided by 2x plus 1. And that should tell us what that unknown polynomial is. But here was the trouble. We now have to go and perform this division. Hopefully you remember the process of polynomial long division. That's where we would take the divisor and we would divide it into the dividend. Here the dividend is the trinomial 6x squared minus 5x minus 4, and the divisor is 2x plus 1. So the process of this, I'm going to move fairly quickly through it, was you take the leading term and you divide it into the leading term of the dividend. So what times 2x gets you 6x squared? Well, that should be a 3x. So 3x times 2x got us 6x squared, and then 3x times 1 got us 3x. We would have to subtract this every time, so I'm going to go ahead and distribute a negative through. So when I add 6x squared and negative 6x squared, they cancel out, and we are left over here with negative 8x. Then we carry down the next term of negative 4. So, and we repeat this process. What times 2x gets me negative 8x? Well, 2x times negative 4 got us negative 8x, and negative 4 times 1 got us negative 4. And we would have to go and subtract all these quantities. So let's change up the colors here, and let's show how we're distributing the negative through. That becomes a positive. That becomes a positive. Negative 8x plus 8x cancels out. And negative 4 plus 4 cancels out. It's just a 0. So our answer, our missing polynomial, is the quotient here, 3x minus 4. We can say that the polynomial 6x squared minus 5x minus 4 is the same thing as 2x plus 1 times 3x minus 4. We have gone through and we factored down this polynomial. We found a way of writing this trinomial as the product of 2 other polynomials, okay? That's the idea with factoring. We need to represent a polynomial as 2 other polynomials multiplied together, okay? You're trying to break down, just like we did with the number. You break down 6 into 2 times 3. We're breaking this polynomial down into 2x plus 1 and 3x minus 4. But here's the trouble. In this problem, all of our work stems on the fact that you knew what one of the factors was. All of this work was done because you knew that I told you, in fact, that 2x plus 1 was one of the factors of this polynomial, okay? I knew that for a fact. But here's the question. Could you have redone this problem? Could you have solved this problem 6x squared minus 5x minus 4? Could you have found two other polynomials that could you have found two polynomials that multiplied together to get you this quantity without knowing either of them? Not known. Could you have done this without knowing them at all? When you were younger and you were learning about numbers and the factors, you had to memorize them, right? You memorized things based on times tables. But you never really memorized polynomials, right? I mean, there's all different kinds of ways of writing polynomials. How can you possibly remember them all? So this is going to be the question that we're going to work through these series of videos. How can we break down a polynomial to find the other polynomials that multiplied together to get this without having to go and memorizing times tables for polynomials? That's the key for this section and for these series of videos. So we're going to work through various techniques one by one and ultimately attempt to answer this question. If you have any questions about this general concept of factoring or about the video in general, please let me know. My email is klinford, that's KLINFORD, at wccnet.edu. Let me know what you thought of the video and any questions that you have. And until next time, take care.